Chapter 8, Right Triangles. Today we're going to cover Section 8-6, Sine and Cosine Ratios. Your class opener. Find the value of x in the nearest degree for number 1, and find the value of y nearest to the nearest tenth for number 2. Section 8-6, the sine and cosine ratios. Our objectives for today will be to define the sine and cosine ratios for an acute angle, and to solve right triangle problems by using the sine and cosine ratios. Again, this only works with right triangles. So if I want to find the sine of angle A, it's going to equal the leg opposite angle A over the hypotenuse. So I can think of this as the leg opposite of angle A would be over here A, and if I'm dividing it by the hypotenuse is going to be B. So sine is opposite over hypotenuse, and if I shorten it up, I can just remember it as so. The cosine, if I go back up to my right triangle, the cosine of angle A ends up being the leg adjacent to A, which is right here, divided by the hypotenuse, and the hypotenuse again would be B. So cosine is adjacent over hypotenuse, or sometimes you just might remember it as cos. So if I put them all together, sine, cosine, and tangent, it would be SOHCAHTOA. And I remember the phrase SOHCAHTOA stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So express the sine of A and the cosine of A and the tangent of A as fractions. And I'm just going to write my phrase SOHCAHTOA. So all of these are relating to angle A. Well, if I'm going for the sine, I remember sine is opposite over hypotenuse. So opposite is 8 over the hypotenuse, which we know is always going to be up at the top, is 8 over 17, and 8 over 17 doesn't reduce, so that's it. Going for the cosine ratio. Well, now if I look at the cosine ratio, the cosine is adjacent over hypotenuse. So adjacent is going to be 15 over my hypotenuse, which is still 17, and that doesn't reduce either. Tangent of angle A. Well, I remember that tangent is opposite over adjacent. So if I look, opposite is 8 over adjacent, which is 15, and it doesn't reduce either. So those are my three ratios. Complete the sine of 24 degrees. So you can either look this up in the table of values or go back to your calculator and just make sure it's in degree mode and type in the sine of 24 degrees. And we're going to round off to 4 decimal places so it would match if you were using the table of values. And I get 0.4067. The cosine of what angle equals 0.9659? So either using the table of values, looking up the decimal, and then looking for the degree mark off to the side, or if I'm going to my calculator, I make sure I hit the shift or second button, type in the decimal, and then hit the cosine button, and rounding to the nearest degree is 15 degrees. Find the value of the variables. Okay. Well, I know for this I'm always going to be using a 37-degree angle. And I know that I'm dealing with the trig function, so I'm going to write SOHCAHTOA right away. And if I'm trying to find the x value in this problem, which I know from the 37-degree angle happens to be the opposite, and I have this 35 up here, which I know is going to be the hypotenuse, tells me I'm dealing with the opposite and the hypotenuse. So opposite and hypotenuse, I'm using the sine function. So the sine of 37 degrees equals the opposite x over the hypotenuse 35. And now I just need to find the decimal value for sine of 37 so I can cross multiply. So back to my calculator, make sure I just type in 37, sine, and 4 decimals again, 0.6018 equals x over 35, cross multiply, and we're multiplying by 35, and if I round this off, I would get 21. Now, I found the value of x. How do I find the value of y? So I go back up to my diagram. So I'm going to still use the 37 degrees. It's the only one I have. I'm going to use the y, and I'm going to use the other exact value, which is the 35. Well, if I look now, I have the adjacent side, and I still have the hypotenuse. So now if I'm doing adjacent and hypotenuse, I'm using the cosine. So I set up a problem, the cosine of 37 equals the adjacent value y over the hypotenuse 35. And I'm going to cross multiply again. Now I'm looking for the cosine of 37 degrees. And the cosine of 37 is going to be 0.7986. And now I just need to go back and cross multiply. And it's going to round off to 28. Alright, try to find x and y. I'm going to write down SOHCAHTOA right away. And I'm going to start to look at my values. So if I have to use this 70-degree angle, I'm going to look at the x, and I have the 30. So from the 70, x happens to be the side opposite, and the 30 happens to be the hypotenuse. So if I'm dealing with the opposite and the hypotenuse, I have the sine function. So setting up sine 70 degrees equals the opposite x over the hypotenuse 30. And again, going to get a decimal value and cross multiply. So for the sine of 70, I'm going to use 0.9397. And going back and cross multiplying. I'm going to get 28. Now I'm going to go back and figure out the y value. Well, to figure out the y value, I noticed this is an isosceles triangle because two sides are 30. So that's going to give me that this angle over here is really 70 degrees. So I'm going to use the 70-degree angle. I want to find y, and I'm going to use the 30. So if I look, I know that y is the adjacent side. 30 is still the hypotenuse. So if I'm looking at adjacent and hypotenuse, I'm going to use the cosine. So setting up a cosine problem. Cosine 70 degrees equals adjacent y over hypotenuse 30. And I'm going to get a proportion to cross multiply. So finding the cosine of 70 degrees, I'm going to use 0.3420. And going back to my calculator, it's going to round off to be 10. And your closure. What phrase helps to remember the trig functions, and what does each letter represent?